this gives you some sort of a straight line, natural log K, 1 over T. Okay, Van Hoff equation looks at the equilibrium constants versus temperature. Once again, Van Hoff equation looks at or compare equilibrium versus temperature. And this is the expression. This is a y equal to mx plus b, right? Plus b, right? So we're not going to use this equation for now, but later on we're going to come back to that equation. For this class, when you have two data points, this equation becomes a much simpler expression. In this case, natural log, the K1 over K2 is equal to delta H over R, 1 over T, 1 over T2 minus 1 over T1. Okay? Okay? So this expression only compare two data points. When we say two data points, what we're talking about? Natural log and inverse of temperature. Natural log of K, inverse of temperature. Two data points, right? This slope expression is enthalpy energy over R. Slope represents enthalpy energy over R. So in this expression, you don't even have to do the calculate the enthalpy or the slope. Is this resembles anything? Yeah, Arrhenius equation, same format. So by now, we should already had that practice. Is that correct? Right? So, I shouldn't even have to go through this yet.
Yeah, please.
So, quiz. What's today's date?
No, 29.
29? No.
No.
27,
27.
27, my bad.
Wait a minute.
Head of my game.
I said 9/27. Okay. Question A. Question A. K1 is equal to 1.03 times 10 to the negative 2. K2 is equal to 1. So 0, let's say 7.03 times 10 to the negative 2. T1 is equal to, so this is high temperature, so this is 20 temperature, so this is a 60 Celsius. T2 is equal to 25 Celsius. Calculate delta H. Okay? Calculate that. B. What is K at, let's say 45 degrees Celsius? Okay? So A and B are related to each other. You have to calculate delta H. And using delta H, go back and calculate the equilibrium at this temperature. Okay?
This is going to be on that test.
Yes. So this is 5-star. 5-star.
That's gonna be one of the questions on the quiz. I mean, on the test.
What's a 5-star mean?
It's gonna be on the exam.
But as soon as I saw first exam, I was a little bit disappointed.
You'll be disappointed in me.
You don't take advantage of the Slade, S-L-A-D-E. Okay. Alyssa? Alyssa?
Last class.
Hmm.
You think it's the last class?
Kelly?
Yeah, very,
Kelly?
very little. I was gonna say, I feel like I read very little. Mm-hmm.
Already graded, this is already scored a Shemaya. Shemaya. Okay, Sanders. McGee. This is from Oliver. Oliver. I know she's here, Asia, Andy. Hopkins, Ebony Hopkins. Brown, Amaya Brown. Francisco. Yeah. Ellie, I don't have the form. Just send me again, okay? Murphy. And. Ashley Gaines. Gaines. Kelly.
That must have been lab too.
Once again, you know my exam format and everything, so you should know. You know exactly what to do.
Some hand sanitizer. You want some hand sanitizer?
Mm-hmm.
You want some hand sanitizer?
I have, okay. It's not gonna kill you. All right. try to check your answer. It's equal to negative 45235 joules per mole. Or you say negative 45.2 kilojoules per mole.
What was that trick you told us instead of having direct?
Okay. All right. Since you guys not sitting in the front, I'm gonna go back and force these people to be the front. All right, so let's plug it in.
Oh, really?
K1 over K2
Wait a minute.
is equal to delta H over R, 1 over T2 minus 1 over T1. Is that correct?
Yeah.
So natural log of 1 is 1.03 times 10 to the negative 2 divided by 7.03 times 10 to the negative 2 is equal to delta H, and R is 8.314 joules per mole per Kelvin times 1 over T2, which is 25 plus 273. Remember that? You have to add 270, convert to Kelvin. So this is 288 Kelvin minus 1 over
333.
1 over 333.
Oh, wait, no, you switched those.
Yeah.
It's 333 minus 298. Yeah.
Ah, so I should have positive answer then.
Wait a minute. That's right. That's right. It's C2. That's right. Yeah, that's right.
It's just 298, not 288.
298. Okay. 298. All right. 298. You don't have this much?
Yeah, I messed up right there.
Yeah. Calvin, do you have this much?
298.
Okay. So it's really, even for me, it's hard for me to keep track of all this. So what I like to do is I like to break it down, each one piece. Which one do you want me to do? This side first?
Yeah.
Yeah, okay, so this is delta H divided by 8.314 joules per mole per Kelvin times, so 298 inverse minus 333 inverse is 3.52 or 3 times 10 to the negative 4. Did you all get that?
No.
Put that in the calculator. See if you
Yeah.
can-
Did 1 divided
Point
by,
353. Yes, I got that.
is that 293 or 298?
298.
And minus
3333.
333.
Yeah. Okay?
I got 4.6 times 10 to the.
Okay, you need to re-punch that number in and get it right. Alright? So
Oh,
I'm gonna take this. So
coming in hot.
1.03 e to the negative 2 divided by 7.03 e to the negative 2. I got 0.145. So this value here is a 1.465. Okay? I'm gonna put that in natural log, okay? So I'll put natural log, answer. Oops, the one. Natural log, answer. Is negative 1.92. Did you get that? No.
I got my number.
Okay. What's wrong?
No, I was just shaking my head.
All right. Everybody okay? Right. Then, what can I do? In order to solve H, what do I need to do? So I need to move everything to the other side. Is that correct? So what I'm going to do is, this is multiplication, then this is division. Is that correct?
Correct.
Once again, don't use this. I like to use EE. Right? So this EE, negative 4 form will be so much easier to use. Okay? Then what do I need to do this? Multiply. Okay? So this is actually Kelvin. So Kelvin cancels out, you get joules per mole. So this is cancel, so you get delta H. So I'm going to multiply 8.314 divided by 3.53 e to the negative 4 equal to, I got negative 45235 joules per mole. Did you get that? All right. What's wrong?
Where did you get, I got lost once you did the calculation with 1 divided by 228, I mean 2, 9, oh, yeah, I know.
Messing up, yeah.
So when I put the law, natural log of like division,
Uh-huh.
it doesn't give me, I don't get.
So you probably put down some sort of multiply, divide in the scientific notation. So you need to put that in a calculator form of the scientific notation.
So-
I got some pretty close up. We got 4,000,
Yeah, it's
45,000.
okay.
I have a question. When we do these, you said you wanted us to use E?
EE.
EE,
I got.
on the calculator?
It was 270.
Okay, because that way it will, come out as a regular decimal and not a scientific notation, right?
No, this is how you put the scientific notation in your calculator.
Okay.
Yeah.
Okay, when I did the last part, I got negative, 45220.6.
Oh, this is close now. Normally you have 45,000.
Okay.
45,000, that's good enough. All right? It's not, the answer is not going to change much. All right, that's a part A. Part B. Okay. Part B. You could use any of these data points to calculate the unknown of a K. Okay? Do you think you could do that on your own? What equation are we using? Second one, yes.
Oh, okay.
All right. So here, if you have 45 Celsius, what is your equilibrium constant, right? So you go back. Which one do you want me to use, data point 1 or data point 2? 1. Okay. So in this case, look, natural log, data point 1 is 1.03 times 10 to the negative 2 divided by K2. I don't know what this is. I'm using this as K2, okay? Then it's equal to 4, 5, negative 4, 5, 235 joules per mole per Kelvin divided by 8.314 times 1 over 45 plus 273, what is that? 318 minus 1 over 0.1 is, what is that? 333. Okay? Go ahead, Saul. What's this number? Yes.
Since in the equation it says like a negative change of H,
Mm-hmm.
would that still be negative? Or would
Yes.
it be like
You have to place it the exact same number.
Would it be like two negatives would counteract each other, so it would be positive, or would it just be negative?
No, you just put in what the delta H was. So delta H in this case is positive. Okay, positive. Okay. Go ahead, put that in and see what you get for K2. K2. What you get? Oh wow, you guys should make me tired. Make me think all this.
What is happening?
How long you been teaching Chem II?
Too many years.
Not long enough.
I'm burning out. Barely, you be the next person to teach this class.
All right, don't speak that over me. I'll go slow
I am.
and fast at the same time.
This is. I'm sure it's unheard of with teaching 2 chapters for 2 months.
No, I think
Alright, it's a little too slow. Alright, somebody get the answer, you let me know, okay? Amaya Brown, not here. Alright, Kelly, she's not here. Kelly, not here. Slade, that's L-A-D-E. Alright, Shemaya, not here. Shemaya. What's going on here? Why is Oliver? Okay. Alright. Oh, couple announcements. Already they found the chemistry tutor, so you're able to sign in. Make sure you have sign into your tutoring session. Once you complete, your tutor will file a report, then I'll be able to see how many hours you worked. Now remember, anybody who got below 50, that's extra credit, right? And 1 per, yes. 1 hour per 1 point up to 5 points. Don't forget, practice exam is 5 points, right? And also an exam I will give out of 105, so that's total of 15 extra credit that I'm giving you, right?
where the extra 5 go?
Huh?
Where 5? You said 15 extra points.
That is considered.
Where's
So,
the? Oh, it's a bonus question on the.
5 points is gonna be bonus points. On exam, right, that's 5, right? Practice exam is 5, right? And if you get below 50, I'm giving you tutor hours, gonna be extra credit.
Okay. Did that count? Did the tutor hours count with like office hours with you too?
No,
Just with the tutor.
tutor. Okay. Spending time with me is not enough.
Okay.
Okay, you need to spend. Also, when you
Did she email you my hours?
what hours? Not yet. I didn't see anything. Once again, homework you do it at home or somewhere else or somewhere. I mean, if I were you, just go tutor and help with your homework, or have a group session and go see a tutor. Okay. All right.
I don't know. I think I did it wrong. I think I did
All right.
it so wrong.
This time,
Okay.
I'm gonna take shortcuts. I'm just gonna go right to the answer because I think we need to move on. Okay?
I did that first. To get rid of the natural law.
Okay. All right. So 4, 5, 2, 3, 5 with the negative. Oops. Whoa, what's going on with your calculator?
You're using mine.
Too fancy for me.
Just the same thing.
Okay. So let's go. There. Negative 4, 5, 2, 3, 5 divided by 8.314 times open parentheses 318 inverse minus 333 inverse close parentheses enter. I got all these. I got negative 0.771. Okay? Close enough
Close
is
enough.
okay.
Yeah.
Close enough. So,
What you get?
That's all right.
right? Now, how do you get rid of natural law?
E. Raise it to the
You raise raised to the E. So I'm going to E. Oh my goodness. Okay, second natural log,
That's right.
second answer equal to. So when I have this, it's 1.03 times 10 to the negative 2 divided by K2 is equal to 0.463.
Wait.
All right?
I didn't raise it.
Okay, wait. I'm confused. I got two, so I'm confused on the right side. I
So,
divided
don't forget, it's negative.
It's negative, okay.
Negative 0.771. So E negative 0.771 should give you 0.463. Okay?
And then we multiply 1.0.
No. So how do you, this is denominator, how do you get this numerator? You just cross multiply. So in this case, 1.03 times 10 to the negative 2 divided by 0.463 equal to K2. Does that make sense?
No, that don't make sense.
Yeah.
Cross multiply.
So, since it's in the numerator,
Mhm.
like you have to,
Cross multiply.
yeah, you cross the
No?
But
Or-
wouldn't
Makes
it
sense,
be
'cause
the
it's-
switch though?
So, since that one's in the numerator and everything.
What? Dividing?
Cause you need to multiply it by 1
So
over.
this is in the bottom. I want to answer for this, correct?
Gotcha.
I think I have.
So
I
how
think
do
I
you
have a
get
way
this
to
to
explain
the other side? Let's do that. Multiply, right?
Multiply
Right.
1 point, yeah, no.
Wait.
I got it.
That makes more sense. There we go.
Divide
Let's
this.
do that.
Okay.
That's it. Do it the way we
Don't
did
be
it in
fancy.
algebra.
That's
that make
right.
sense?
Yes, it does. Now it makes sense. Well, we can do that the first time.
That's what I'm thinking.
Or, there's a way, I think. of it,
Multiply?
like, I mean,
Wait, hold this again.
since
Wait, hold this again.
both of them are in the numerator, like, multiplying it to the other side.
What do you mean by multiply? You cannot multiply this to this
Yeah, but you multiply on
Cannot.
both sides and cross it out.
because the equal sign here. So you have to do something here. You have to do the opposite. Okay, this, look. Okay, you tell me how to solve K2. It's in denominator.
That's
So
right.
you get it to the top, so you flip it, so you put 103 in.
So when you flip it, okay?
It becomes
Look.
negative.
When you flip this, you also have to
Bring it
flip
back.
this. Is
Right.
that correct?
That's right.
So you're saying K2 divided by 1.03 times 10 to the negative 2 is equal to 1 over 0.463,
Harder now.
right?
That's right.
You take this to this, take this number to here. Is that correct?
Mm-hmm.
Same thing. That's what I
It's the
did.
same thing, yeah.
I'm just gonna multiply K2 on both sides and divide and keep it moving.
Okay, you tell me. How do you do this then?
Multiply K2 on both sides and divide 0.464 and keep it moving.
Do this. Somebody do this. Do this.
It's 0.0222.
0.0222. Is that correct?
Yeah.
So this is 2.22 times 10 to the negative 2.
That's what I got.
Yeah, I don't understand.
What's he say?
What's the answer? 222, right, okay.
You said, what's the answer? Oh,
This
got
takes
that.
almost whole class. We can't have time. So
It is.
there are men. That's what the homework for and practice exercise. All right, listen up. Listen up. Wait, hold this again. Hold this again. Now listen. Now how do you check this answer? Look at this. Temperature is 60 between these two numbers. Is that correct? So 40 is in between. Is that correct? So this is 1 and 7. So answer should be falling in between these two numbers, which is 2. 2 is falls in between those two numbers. So answer is approximately correct. Okay. So remember, I told you this will be an exam. You already know. Don't waste So once again, you don't have time to figure things out. Do you understand? When you have this problem, you just right away start tackling, writing something down. Right? What's the first thing you're gonna write?
The equation.
Equation.
So we'll not be given that. We gotta remember that.
No, I give it to you. Okay. So number one. One, writing the equation down. At least you know, listen. At least you know what equation you're using. Right? Number two.
No.
This, that would be 2 points. This would be 15 points.
Oh.
This would be 5 points. Okay? All right? What happens all the time? Once again, you guys are general chemistry too. I should not see, listen, pay attention. I should not see this. I should not see this. You understand?
Oh, okay.
What do you need? You need psi equal to units equal to some value. Is that correct?
Yeah.
So that's 20. So this will be same process. So this will be 10. So I'm almost like, oh, that should be 10, 10, 10, 25. Yeah. Yeah, sure.
What is, for this one, what is the unit for?
What's the unit for equilibrium?
Nothing because it cancels out.
No.
Oh.
But it doesn't have one.
It does not have one because it's comparison. Comparison between product and reactants, right?
Mo.
Right?
No, I guess at this point.
Okay, make sure you practice this. Don't disappoint me, right? When I go home, when I don't have the paper towel for this.
So we're done.
All
Oh, we ain't gotta remember nothing else.
right. Huh?
We're done, right?
No.
We got more stuff we gotta learn.
Just today.
This is the last topic.
Oh my God. I'm pretty serious. Van Hall.
All right. This is the last topic for this chapter. Once again, what affects the equilibrium, temperature, concentration, and pressure and volume,
Say
correct?
it one more time.
Concentration, pressure slash volume. Third one is temperature. Okay? Now, in my class, we talked about Hess's law. So this is one of the problems if you're taking somebody else in a Gen Chem 1, because this is they do not cover this, and it's going to be very challenging. So what I'm going to do is I'm trying to make it easy as possible, okay? So in this topic is called
Oh, yes, what we just did.
sum of the reactions. So you have a multiple equilibrium reaction. Using those multiple equilibrium reaction, you could figure out the third equilibrium reaction with the constant values. Okay? Here are the rules. You could use reverse the equilibrium. So if you reverse the I will give you an example. You could use, these are the two rules you only know to use. One is if you reverse the reaction, you inverse the K value. What do you mean by that? I don't have a pen here. Oh, I.
Here.
Why did they take, no, why did they
Me
take
neither.
paper towel?
Oh.
Oh,
You said you got a pen.
I just don't understand this place here.
I have the timing.
well, we going over here.
NH3, we did this today, somebody asked me this, very good. CO minus, right? So in this case, if I have K, this is NH3, NH4, plus Cl, plus. This is the expression, is that correct?
Yes.
Is that correct?
Mm-hmm.
Right? So what I'm going to do is I'm going to reverse the reaction. So look at this. If I have NH4 plus Cl minus, how do you write the expression for this? So remember, this is solid. So you say K is equal to 1 over NH4. Is that correct? So when you reverse the equilibrium, you inverse the K. So in other words, you put 1 over K. Do you understand? From the original item. Okay, so this is, let's say this is 1. Okay? That's what that means by reverse the K. If you reverse the equilibrium. Number 2, when you multiply, let's say this equation needs to be multiplied by 2. What do you do to the coefficient here? What do you do with the coefficient in equilibrium? You raise it by power, right? Right? So in other words, this is, when you multiply this by 2, you raise the equilibrium to the power
Of 2.
2. If you raise it by 3, you multiply by 3. That's what the rule number 2 says. If you divide by divide by equilibrium, then what you do is you take a reciprocal. So in this case, you divide by 3, that means 1 over 3 power. That's the reciprocal. Okay?
Papa rules.
When I divide this by 1/3, when I multiply this by 1/3, this will be 1/3 power, this will be 1/3 power, so you're multiplying by 1/3 power.
Okay.
Okay, that is called reciprocal, or take a cube root, square root, whatever. Okay? That three rules gonna be applied when you combine equilibrium. Okay. Now, do you remember previously on kinetics, when you add those elementary species, you get the final equation?
Mm-hmm.
Same concept. You're gonna combine all that and compare to your question. All right, so let's go through that exercise. Okay? So what I'm trying to say is, I'm going to already explain this to you. Let me see. Where's the question? All right, where's the question? Where's the question? I don't have the question? I'm just gonna go to this. There it is. All right. So these number 1 and 2 are equilibrium equation. Do you understand? Third equation is the equilibrium equation that I want to solve the value for. So what I'm going to do is I'm going to combine 1 and 2 to calculate the equation 3. That's what I'm trying to achieve. Do you understand? Who does not understand, raise your hand. Yes.
Okay, just go over one more time.
So equation 1 and 2 are equilibrium equation with the K values. So what I'm going to do is I'm going to figure out equation 3 by using combination of 1 and 2 equation,
Okay.
because I don't have the value for the K value. Do you understand? Equation 3. Exactly. What I'm going to do is use 3 rules that I just mentioned to adapt to equation 3. Any other
Just
questions?
like that thing in first, is that Hess's law you were talking
Yes,
about?
yes.
Where we make it fit to the.
Exactly, exactly.
what?
Go ahead.
Watch
Anybody
out,
else?
y'all.
Somebody raised the question. Okay, somebody raised the question. Okay? Now, in order to do that, in my class, we talked about Hess's law. What you need to do is you need to find the unique substance in equation. So if I'm working with equation 1, I have to do with equation 3, but not appear in equation 2. So you need to find the unique substance that only appears equation 1 and 3, but not on equation 2. Once again, can you find some unique substance that appears in equation 1 and equation 3, but not on equation 2? Do you see anything? Which one? Which one? Three?
Two F negative, they were saying
So do you see anything? Oh, my shoulder. I'm getting old. I think I have arthritis in my shoulder.
Stop speaking that.
So did you find the substance? Which one?
Yeah.
F? Let me see. Yep, F is here, right? So we're gonna pick, okay? So we want to have like equation 3. So first of all, equation 1, you say F. You want to pick this, correct? Now, between equation 1 and 3, is that right-hand side of equilibrium or left-hand side of equilibrium on equation 1?
Right.
Right, and same side as equation 3, so you do not have to reverse. Do you understand? It's the same side, you don't have to reverse. Does that make sense? All right, that's number 1 rule, you could eliminate that. Number 2 rule, how many moles do you see on equation 1 and equation 3?
There's 1 in equation 1 and 2 in equation 3.
So in order to have equation 3, I need to multiply equation 1 by 2. Do you see that? So when I multiply equation 1, I'm multiplying 2 to the equation 1. Because I only have 1 mole and 2 moles on equation 3. Okay? So in this case, 2HF equilibrium H plus 2F minus. Do you all see what I did? Then what do you do to the KC? I
Times it
have
by
to
2.
square, no?
Or just square it?
Anytime you multiply, you raise it by power. Does that make sense?
Okay.
So in this case, what is the 6.8 times 10 to the negative 4 square? What is that?
Hold on. 6.8 times. Wait.
4.624.
Wait, just 2 numbers. What is that?
4.6 times 10 to the negative 7.
Negative 7? Did you all get that? Yes, no? All right. Then we're done with equation 1. Next, I have to go to equation 2. Between equation 2 and 3, do you see something that is common but does not appear in equation 1?
And 2
Huh?
is the H2C2O4.
The HS, 2HS.
That's in 2 and 4.
So he says this substance is in equation 2 and 3, but not on equation 1.
That one is
Yeah.
in the H2C2.
Okay, we
That's
just pick
right.
one.
Okay.
Do you all see that?
Yeah.
Yeah.
I'm picking this. Is that correct?
Mm-hmm.
Yeah, it doesn't matter. You could pick either or. You just find a unique one. That's okay.
So, but it's possible that there can be 2 unique ones, but you have to just choose one.
Yes. okay? Now, let's look at the first rule is equilibrium, which side? C2O4 is on the left-hand side on equation 3, by the right-hand side on equation 2. So what do I need to do to equation
Flip number 2.
2? Flip it, correct? So in this case, reverse equation 2. Reverse equation 2, okay? So in this case, I have 2H plus C2O4, 2 minus, equilibrium H2C2O4. Do you all see what I did? I reversed it, correct? So then what do you do to KC? KC, what do you do? If you reverse equation, not
No, put it
sign.
on the bottom.
No,
It's negative.
no. Inverse. Put over 1, right?
On the bottom.
Right? So in this case, 1 over 3.8 times 10 to the negative 6. What do you get? What do you get?
Oh, wait, we got
Um,
to calculate.
1, 2, 3, 4, 5, 6. 2.6.
2.
2.63.
Just 2 is okay.
Oh.
And times 10 to the
Then make it 3. If you just gonna do 2.6. You wanna leave it at that?
2.6?
Yes.
That's what I have.
Okay.
And times to what?
1,
5?
2, 3, 4.
Is that right? Is that right?
I think so.
Yes, no? Okay. Now, how many moles of a C2O4 do you have? 1 mole? 1 mole. So I don't have to multiply. Do you see that?
Okay.
I got 2.6.
All right. Then we have to do the last step. All you have to do is once you're done with those 3 rules to each equation, we just add them all. That's it. So when you add this, I should be able to do this. Equilibrium, equilibrium. 2 moles of H, 2 moles of H. Do you see anything else that can be canceled? No. So I'm going to bring it down. 2HF plus C2O4, 2 minus H2C2O4 plus 2F. Is this same thing as the equation 3?
Yes.
All right. Then what you do is, when you have this, all you have to do is multiply these 2. So in this case, 4.6 times 10 to the negative 7 times 2.6 times 10 to the negative 5. What do you have? What do you have when you multiply those 2? Oh, this is plus. This is plus.
1.196 times 10 to the negative 11.
No. It can't be.
He said, no, that's not right.
1, 2, 3, 4, 5, 6.
So 4.6 times 2.6, what you get?
I did.
10 to
Huh?
the negative 7. I got points. I ran out of space on mine.
You want
Doesn't
scientific?
matter.
Oh.
1.1 times
1.1.
times 10 to the negative 11.
It can't be.
I got 11.96.
0.1196. So
0.1196. Okay.
So it's gonna be negative 1. Let me see that. 1, 2. 1, 2.
1, 2. Okay.
Okay. That should be the answer. What you're doing it wrong is
I
this
got
is
it.
what you're doing. I guarantee you, you guys are using this.
And
Then use E. 4.6 E negative 7 times 2.6 E 5. This is positive. So by how I know that? Because when I multiply these exponents, I should have some sort of a negative 2 power.
So
Yeah.
well, 0,
I got
we got,
1.2.
using E, you get
1.2.
0.1196. Which is
0.12.
1. Okay, that
I
makes
got,
sense.
well, I got 0.1196.
Yeah, yeah.
That's fine.
So or I put it in scientific notation.
Negative, so if you get that and then do the negatives, I mean the scientific notation based off of this number, that makes sense.
This is to be, okay, this is called combining equilibrium, combination of equilibrium. And answer should be 0.12, okay? 0.12. Okay? All right. You try to do this one. I don't have time, so go ahead, finish this up, and I will pass back to you Monday. Yes.
Oh, so we gotta do it. Okay.
Yes, this is part of the quiz.
Okay. We got 25 minutes. Group effort.
Lord Jesus, keep me there.
Yeah. Well, no, it wouldn't be. It would just be number 2.
Minus 30. Hey, Wednesday.
All I did was negative 1.9 times 8.314 divided by 3.5 raised times 10 to the power 4. Hey guys, I'm not gonna go over this, so you try to do it.
I am not, I don't know. I don't know yet. Let me see.
What's adding 1 but not 3 is this one. So we don't have to do anything, but what do we do?
Yeah.
Who's the tutor for the session?
Huh?
Who's the tutor for the session?
Michelle Dees.
She's still here.
Yeah, she came back to tutor. I asked her, and asked her favor to come back.
So you paying her? You paying her?
Huh?
You paying her?
What?
Are you paying her?
University's paying her.
Is the research thing still going?
What research?
Remember you was like you paying students to do the research job?
Do you meet the qualification?
I don't.
I
It's
did
okay.
actually.
Okay. Well then, unless you email me and let me take a look at your profile.
Oh, okay. I see.
Okay? All right. this. I want you to do this. Oh, listen.
Right, we need some more practice.
Actually, you're. All right.
Completely forgot.
So,
They call you out. It beat you.
remember, okay. I should go over this. What is that? Solving equilibrium concentration, or K, that should be about 25 points. Well, with the Van Hoff equation should be another 25. So this should be 15. So that should be, what is that, 55? Is that 55?
Mm-hmm.
And then converting KC to KP should be 10 points. So that's a 65 plus,
Have you talked to Michelle? Does she know what we're doing in class?
she already had all this stuff. Yes.
So what's this? What's the
This is called sum of the equilibrium reaction. Calculating equilibrium constant with the sum of the equilibrium reaction.
Okay, so between 3 and 1, the unique compound is N2O, right?
And no, look at 1 and 3. Do you see something unique that is not appearing in equation 2? NO, right? NO.
Yes.
So first of all, is that on the right hand side?
Yes.
Right hand side, so you don't have to reverse. Second of all, is it 2, 2, right? 2 and 2. So do you have to multiply or divide? Nothing. So equation 1 is as it is. You don't have to do anything.
Oh, but because the other one, see, I knew I was right.
Does that make sense?
It does, so I know we have to switch it, but I don't know how to do
No, you don't need to switch it.
the second one.
Oh, I'm dealing with 1. Okay, now go to equation 2. So we're done with this one. Equation 2. Do you see anything unique that appears only 2 and 3, but not on equation 1? N2O. All right, let's look at N2O. N2O. First of all, this is the right-hand side, this is the left-hand side. Is that correct? So I need to reverse this equation. Is that correct? When I reverse the equation, what's the KC?
1 over 2.4.
Exactly. Correct?
Can't we
Now,
just,
wait, wait.
oh, sorry, my bad.
When I reverse this equation, how many more?
1,
How many more?
1.
So you don't have to multiply or divide. All you have to do is reverse. Add these two equations, see if you get the third equation.
What if we chose 1/2?
Right, that's what I meant,
Yes, sir.
2.5.
So then on the last one, we're combining them. Does it
You
matter-
multiply.
multiply
Oh,
what?
you combining those?
Yeah, it doesn't matter what side of the like reaction is on.
No, it is important. You need to reverse it or multiply to make it look like this.
So one choice of what we choose is better than the other, because 1/2 of oxygen, of dioxygen, about whatever it is,
I see what
O2
you're saying.
is
Listen,
the same.
1 is equal to 1/2 plus 1/2. Is that correct?
Mhm.
So can you cancel out the half on both sides?
Yeah.
Okay. I don't need to.
What?
No, you. I assume that you know a little bit of algebra, right?
I remember.
All right. All right. So that's it for today. Wow.
We got 15 minutes. Don't breathe on
You know what?
that now.
You see all this gray hair? All this gray hair is coming from you guys, I
It's
guess.
wisdom. You're getting even smarter.
No, I'm
That's
getting
right.
old. All right. So when you're finished with this, you can leave your quizzes right here. And also, good thing is, if you already know this, help somebody else. Double check the answer. Show them how to do this. Don't be selfish.
Don't gatekeep.
Huh?
Right.
You have 3 of you. You have 4 actually. Sneed, the person behind you. He already should know. So ask him.
it's not in the other. So, oh, Sean, you did okay. So now that you have, so did you just read with the reversing it and whatnot? Let me do that one and I'll do
I don't know what I did today, but
yeah, once they
I'm gonna go to his office hours, so yeah.
Right?
I forgot.
So it's a left, right hand side, right hand side. So I don't need to right? How many more? Two more? Two more. Same more. So you don't need to do anything.
Now,
That's why I.
And four, you cannot pick up equation one because it's not on equation one. It only applies to equation one. Then you go to equation two. Compare equation 2 and 3, but not equation 1. You say M2, right?
Yeah, okay, the first one I did
now you
that,
got
that's what,
this.
I'm talking about the second one, you have to compare.
So now you need to try and find the unique
So,
compound.
now, where were you? I take.
So it's on right hand side, left hand side. What do I need to do in this equation? Flip it, right? When I flip it, this has to be inverse. That's correct? Now, next step is, how many more? One, but we need to multiply anything. So all you have to do is the inverse of this.
Oh, okay, so I still do it.
Yeah.
Okay, that's where, okay.
I send that through university system. Well, are you interested? Biology major? What's the GPA? You should have gotten my email then. Okay, I'll send you, you send me an email, let me take a look at your profile, then I send you the application. All you have to do is fill in the form. Okay, and have the interview, then complete the employment system. Okay. What?
I wasn't here on Monday. Can I come to your office tomorrow and catch up about it?
Yeah, what do we go over Monday? Oh,
We started this.
let me post the notes, then let's meet on Monday. Okay? You know how to go to make appointment through the navigation? Go through navigation and make appointment. I send out email to everyone how to make it. Oh, by the way, I still need your note for last, what is that? Today's
last
Monday. I still did not receive any good lecture notes from
Well,
you
I
guys.
gotta finish mine.
So if you send it to me, if it's really good, I would like to post them. Yeah. Mhm.
Love this. Where'd you get it from?
Because we picked this element, correct?
Really? That is
So this is on right hand side, this is left hand side. I need to reverse it. Because I picked this one, correct? So it's on right hand side, right hand side, correct? How many more? Two. So I don't even have to multiply or divide. Yes.
So what about the half? Because I went on and chose the N2O.
So
and flipped
this
it.
is in the so
Where you gonna put this?
yeah, put it there.
I know.
We should go ahead and sit back down.
I'm gonna just do watch this. Or I'm gonna use the other one. Watch. So I can just leave it as it is.
So you probably have this. You probably have this, right?
Yes.
So
Yes.
this half, this is one. This is same thing as 1/2 plus 1/2 O2. Right. So look, this could cancel out one of these, one remaining.
Oh.